Assalam- Assalamualaikum warahmatullahi wabarakatuh. We are from Group 19. We will present about software maintenance and evolution, which is Reengineering. And our group consists of me, Muhammad AMYRUDDIN bin SHAMSUDDIN, 50801, and NORA ATHIRA YASMIN binti KASSIM, S52121. Okay, proceed to introduction. Okay. Somerville defines software maintenance as when the transition from development to evolution is not seamless. The process of changing the software after delivery is often called software maintenance. Maintenance and evolution of software is important because software is crucial to company success and because software is very complicated. In today's world, most of the software budget is spent to modifying existing software rather than developing new software. Software reengineering is a process of software development which is part of the maintenance and evolution of software, which is done to improve the maintainability of a software system. Reengineering is the examination and alteration of a system to reconstitute it in a new form. This process includes the combination of sub-processes like reverse engineering, forward engineering, reconstructing, and many more. A software product reengineering is a software upgrading procedure or improvement to a more advanced technology platform. At the same time, its current functionality is still the same or undergoes slight modification. Typically, software engineering process includes one or more procedures such as source code translation into another programming language, database reorganization or its transfer, software architecture optimization, new functionality addition and integration with third-party APIs. We proceed to review papers. Okay, first review paper is the topic is Reengineering Framework to Enhance the Performance of Existing Software. This research paper proposes a framework for determining the need for reengineering, for estimating the cost of reengineering, and for validating and improving software quality. The research will use agile methodology to perform re-engineering tasks due to the flexible and interactive approach to software development. Re-engineering is applied using Scrum's agile methodology. All three re-engineering assignments are included in one 3-week iteration race. Re-engineering needs are identified using a prediction-based decision tree approach. The dataset consists of 20 software systems divided into two parts, which are training dataset and sample dataset. The research work considered 15 software projects as a training dataset and 5 as a model dataset for implementing forecasts using a decision tree approach. Average interior design complexity and size of software systems serving as the two main metrics. Re-engineering cost is estimated considering the cost of human resources, time required to complete the task, cost of other resources required, which are hardware, software, licensing, and anything else. Sprint is planned, and the time of one sprint is estimated. The cost is estimated using story point estimation. The cost estimations are also realistic and involve a consensus of all stakeholders. Performance analyses are performed using complexity matrix analysis of interior design matrix and average time to measure execution. The search used various automated tools such as EKJM Framework version 1.9, Rapid-Studio version 7.1, and NetBeans 7.3. We proceed to the second research paper. Okay, for the second review paper, the topic is Enhanced Reengineering Mechanism to Improve the Efficiency of Software Reengineering. Enhanced reengineering mechanism is a software reengineering process that exploits not just a single but a mixture of abstraction methods and abstraction levels to transform a traditional software system to a new software system. This enhanced reengineering mechanism consists of five important phases. These are feasibility study and requirements, pre-structured system requirements specification, design to code, comparison of existing and proposed functionalities, and implementation. In order to analyze the performance of this proposed engineering mechanism, a series of experiments that related with diseases such as breast cancer, diabetes, and heart disease were conducted. In this proposed system, it has created one medical diagnosis and prediction system for the three diseases. Here it considers two medical diagnosis and prediction applications such as naive-based classification system and SVM classification system. Initially, this system evaluates the performance of naive-based classification system by taking three types of datasets as an input for classification process. This classification system works based on the probability distribution of each dataset and it efficiently predicts the diseases. This prediction fully depends on the probability distribution, but computation time of naive-Bayes classification system is too high. Later, it evaluates the performance of support vector machine classification system and the same three types of disease datasets are taken as an input for classification process. This SVM classification system classifies datasets based on the training process. The system also effectively predicts the datasets, but the computation time of this algorithm is very low. So, based on the performance, the SVM rating system is better than the knife-based grading system because the time consumption and prediction accuracy of the support vector machine is very high. In order to improve the knife-based rating system, software reengineering is required. In this proposed reengineering mechanism, there is no need to re-engineer the entire classification system. Instead of the knife-based classification algorithm, this system replaces the vector support device. Therefore, the performance of the existing rating system is also increased. This proposed re-engineering reduces the complexities of the software re-engineering process. Okay, proceed to the third review paper. The third review paper, the topic is study of software development using software re-engineering. After conducting the study in this paper, it is concluded in the article that the software re-engineering is the process through which the project costs, time, and efforts of the project can be easily decreased. In spite of developing the whole project, the developers prefer to use some of the already developed sections of the previous software. When the requirements gathering process has been executed of any software, the data that will be collected will be either useful or useless data. By using re-engineering methods, one can easily collect the useful data and all the useless data can be rejected. This method uses the priority method by giving high priority to the data which is more important and giving low priority the data which is less important. The advantage of this method is that the time and cost is less consumed and the best possible requirements are generated for the development phase. It also stated in the article that legacy software exists everywhere and sometimes makes the maintenance costs become unbearable. When this happens, re-engineering is the only option to reduce maintenance costs and to avoid software development. Re-engineering can reduce the overall investment on the software in the organization, and some of the benefits of reusability of software components are as follows. First is increased reliability, components exercise in working system. Second, reduces process risk, less uncertainty in development costs. Third is effective use of specialists, reuse components instead of people. And the fourth one is accelerated development, which can avoid original development. Okay, next to the fourth review paper, I give it to my team member.
Okay, so the fourth paper that we have reviewed is an effective approach to improve the performance of software engineering. This research paper discusses that object-oriented patterns supported dealing with the issues connected to the change of this object-oriented system (OOS) into the more reusable system and instrument, which needs methodologies or tools maintenance to handle huge and badly documented OOP. In this paper, it is also mentioned the tax, taxonom, taxonomy and scope of the software engineering areas. There are 9 of it, which is forward engineering, reverse engineering, redocumentation, plan recuperation, program understanding, rebuilding, record, redesign, and reindicate. So for forward engineering, it is the conventional procedure of moving from sophisticated logical and abstractions execution, not dependent designs to the system's physical completion. Reverse engineering is the analyzing process of software system to make out the software's interrelationships and their mechanism and generate system representations of the current system in a different structure or in a higher abstraction level. Redocumentation is the revision or creation of a semantically correspondent illustration inside the similar comparative level of abstraction. It is also the oldest and simplest reverse engineering form and should be measured to be an uninvasive weak restructuring form. Plan recuperation or design recovery recreates abstractions of the design from a mixture of existing design documentations, code, personal experience, application domains, and general information about the problem. Program understanding or program comprehension is a term that is related to reverse engineering process. Program comprehension or understanding implies that comprehension starts with the program, while RE may start at an executable and binary structure of the system or at sophisticated descriptions of the system design. Rebuilding or restructuring is the process of transforming the data from one representation structure to a different at a very similar comparative level of abstraction, while protecting the existing software system's semantic and functionality. Record processes consist of alternating the implementation characteristic of the program, control flow restructuring, and language translation are the program level changes. Redesign is the process of modifying the characteristics of design. Visible changes contains improving an algorithm, restructuring design architecture, changing a data of a system model as incorporated in database or in data structures. Reindicate or respecify process consists of modifying the characteristics of the requirements. This kind of change may refer to altering the existing requirement structures only. This paper also proposed a work in which it is called efficient and enhanced software engineering mechanism. It is a software engineering process which is used to transform a traditional software system to a new software system. Okay, so the last one is the need of re-engineering in software engineering. Okay, so the article discussed the evolving needs of software engineering, its goals and benefits. There are four reengineering software reengineering goals, which are provision for the functional improvement, boost maintainability, migration, better dependability. The primary advantages of software engineering are maintainability increment, better performance, expanded interoperability, diminish personal dependency, enhance testability. So for increased maintainability increment, it is said that many resources are spent on software maintenance, thus producing software that is easy to maintain may potentially save large costs. Since re-engineering main goal is to boost maintainability, so the problem of maintaining software is widely acknowledged in the industry, and much has been written on how maintainability can be facilitated by tools and process. However, it is said that you cannot control what you cannot measure, and there is yet no universal measure of maintainability. Maintainability is the ease with which a software system or component can be modified to correct faults, improve performance or other attributes, or adapt to a changed environment. Next is better performance. Performance, responsiveness, and scalability is a make or break quality for software. Poor performance costs the software industries millions of dollars annually in lost revenue, decreased productivity, increased development and hardware costs, and damaged customers' relations. When performance problems occur, they must be fixed immediately. In response to the project often goes into crisis mode in an attempt to tune or even redesign the software to meet performance objectives. In this situation, it is vital to maximize the performance and capacity payoff of the tuning effort. Uh, there is a systematic quantitative approach to performance tuning that will help to find problems quickly. First, figure out where you need to be. Second, determine where you are now. Third, decide whether you can achieve your objectives. Fourth, develop a plan for achieving your objectives. And the last one is conduct an economic analysis of the project. Using this approach has been shown to provide a high payoff or relatively small cost. Once you run into trouble, tuning the software is likely to be your only choice. However, it is important to realize that a tuned system will rarely, if ever, exhibit the level of performance that you could have achieved by re-engineering that system. Next is and expanded interoperability. The IEEE Standard Glossary of Software Engineering Terminology defines interoperability as the ability of two or more systems or components to exchange information and to use the information that has been exchanged. The Department of Defense directive defines interoperability as the ability of systems, units, or forces to provide data, information, material, and services to and accept the same from other system units or force, and to use the data, information, material, and services so exchange to enable them to operate effectively together. Next is diminish personal dependency, or in other words, decrease personal dependency. Large scale software development requires coordination within and between very large engineering teams, which may be located in different buildings on different company campuses and in different time zones. Coordination between software development teams is one of the most difficult to improve aspects in software engineering. Researchers have studied professional software development teams empirically to gain greater understanding of how software development process, tools, and people impact coordination. Coordination is a decision making that requires communication capacity or limit and cooperation. These three components of coordination are necessary but by themselves insufficient for coordination to take place. Communication is necessary because person A needs to communicate to person B in some form what needs to be done, and B needs to understand the communication. Capacity is necessary because B needs to be able to do what is required for them. Cooperation is necessary because B will need to be willing to do what is required of them. If any of the three necessary components are lacking, the outcome will be less than ideal. And the last one is enhanced testability. Test scores are driven by the size and complexity of the software. Size can be measured in terms of the number of elements making up the system. This could be statements, methods, classes, components, interfaces, files, database, tables, and GUIs. Complexity is measured in terms of the number of interactions between elements. This could be associations, calls, messages, file transfers, database access, import, exports, and events from outside. The less there are, the less there is to test. A very critical factor in testability is the separation of the user interface from the processing logic. This separation of presentation from processing is a prerequisite to testing the processing. As an example, the business logic. Without having to enter the data in the user interface, which requires a lot of time and is difficult to automate, a final factor in reducing test effort is the separation of the data access operations from the data processing. The goal of reengineering for testability is to restructure the software in such a way that testability criteria can be met while at the same time reducing the size and the complexity of the system. And that makes us proceed to conclusions. So these are the conclusions that we able to take out from all the five papers. First one, nowadays software and technology not only intensively develop but also go out of date at railway speed. By using the software engineering process, it allows to modernize the use system and eliminating the technical problem that exists before. It is also bring the other advantages such as reduces the cost of services, expands its capabilities in terms of meeting business needs, and refine the system functionality and increase its flexibility, ensuring better compliance with the other enterprise's current objective. A novel software engineering procedure is needed as new software application enhancements are riskier these days. And the last one is software engineering is a valuable tool that can change the old outdated frameworks to be more productive and smoothed out frameworks that thus organization go through tons of cash to maintain their old inherited software frameworks, which contains implicit data and decision that they not afford to lose over some maintenance. That's all from us. Thank you.
So that's all from us. Assalamualaikum and thank you.